So today I would like to present this our latest data to show you the interaction of central serotonin transporter biomarker and peripheral tryptophan kynurenine biomarker system. So this is my hospital, which is the biggest hospital in Taipei. It's more than it's around 3,500 beds. Yeah, that's a background. Why I want to do the patient with MDD because still MDD it's still a challenge for clinician. Not only the treatment, but also some public health problems. So it's one of the most burdensome mental illness. Even we try to do a lot of study, but the serotonin hypothesis still mainstream for the study of pathophysiology of MDD. That's the serotonin hypothesis. I don't want to give you too much because I know almost all of you know this story, but I just want to point out these 3 points. From the animal study, the serotonin depletion agent can cause depression, and SSI, of course, is very popular for clinical work, and that can recover depression. But of course, depression may be not only related to serotonin transporter, but also other serotonin receptors. In my group, I did this first study. We developed the new tracer for the image of serotonin transporter. We call CERT image from 2008. I did the first kinetic analysis, and which means we know the protocol and how should we scan this radioligand. That's our recent publication. We try to link the peripheral and the central marker together and give you more information about the pathophysiology of MDD. That's the paper we discussed about the interleukin-1 family and their effect on the serotonin transporter. To my surprise, since I didn't follow the geriatric psychiatry for a long time, so when I did this study, I found there is a English name called inflammagine, and I didn't know that, and I cannot find that in the dictionary. And then I use Google. I found this term is quite interesting. It's an inflammation plot agent. So it seems the tryptophan metabolic system is quite important for our brain. And nowadays, in Taiwan, a lot of rich person, they buy the tryptophan as a food supplement since they think they can give more tryptophan and let their mood stable. And so I try to figure out how should we give the tryptophan, and is that truly good for our brain? So this is a new term called inflammagine. The tryptophan, if you give the tryptophan, and a lot of people will think tryptophan will go the right way to the serotonin, and the serotonin can go to melatonin. But unfortunately, in our body, we have a lot of inflammation situation. So when you get the inflammation, the cytokine could activate the metabolite enzyme called IDO or TDO. And then the tryptophan maybe will not go to the right side, but instead of go to the left side. And then this will become the kynureninic acid and the cholinergic acid. Cholinergic acid has something like the NMDA, and this could induce the neuron death. So I always talk to my friends, if you want to supply more tryptophan, maybe you should add on the aspirin to inhibit your inflammation. Otherwise, this might go to another way. Yeah. Okay, so So the aim of this study, as I just mentioned about, we think we try to find the association between the central marker and the peripheral marker. But of course, we hypothesize there should be some association between these two systems. We just try to know. So all participants, it's age 20 to 65, and we recruit 33. First episode, drug-naive major depressive disorder, and this patient should fulfill the criteria of DSM-4-TR, and each participant we will evaluate by mini before enter this image study, and the severity of depression will be evaluated by Madras scale. For the image process, we use a radioligand iodine 123, which is a quite nice radioligand for the image of serotonin transporter in the brain. And we are the first group to develop this tracer and apply this tracer in the human study. And of course, all the patients, they should have the MRI acquisition, because we should use MRI to do the image analysis. MRI is good for the anatomical region, since the SPECT image is the resolution is not very good. We use the two-head camera. It's very popular for clinical use, equipped with high resolution film beam. The spatial resolution is about 7.3 millimeters. And we also measure the plasma tryptophan and kynurenine, but the method is we use commercialized ELISA kit. In the last slide, where I will discuss about this, the drawback to use this method. Of course, we have to do some mathematical analysis, like we use semi-quantitative analysis, and we use statistic analysis, because this sample size is not very large. We use non-parametric statistic, like Mann-Whitney U and Spearson rank test. But it's worthy to mention, since it's a quite small sample size, since the procedure is very complicated. So we use arithmetic called Hartigan trip test. We wanted to get a cutoff. I will talk this about later. Let's take a look our result. First, it's a demographic data. Since it's age sex matched, it's a very very match, and only the education level, but it's not a very big difference. First, we should find out our serotonin transporter availability, which reflects the receptor density and the binding affinity. So unfortunately, there is no significance between the healthy control and MDD. When we compare with the peripheral marker, we found there, of course, it's a negative result. There is no tryptophan, no differences between the tryptophan and the kynureninic acid. But what's interesting is we use another indicator. It's a ratio of tryptophan and the kynurenine. It's very, very common. We call the DBI index, tryptophan metabolite index. We found in healthy volunteer it's a little bit high. I will talk about this clinical implication for this TBI. Of course, we use the Hartigan strip test. We found actually we can have a cutoff and put this data into two groups. Even you can see the two groups, the sample is imbalanced. But we use this test, and this test tells us this is feasible for our study. And we found only the cutoff is about 0.056. And we found only the TBI less than these values, and we can find the negative correlation between the TBI and this plasma tryptophan and the kynurenine. So, but not these findings cannot significantly find in the more than 0.056. Okay, lastly, we move to the discussion. Since the finding is not very significant, but still we needed to know what clinical meaning we can choose from this data. So first, of course, the third availability between the MDD and the healthy volunteer. We can find many previous studies, but most of study, our result, our negative result, is consistent with most of PET and SPECT study. There's no differences between the serotonin transporter. Even some of them get positive. But most of paper, they show serotonin availability has no differences between the healthy and the MDD. But I want to stress our group. Our group is the largest sample group. We evaluate the MDD. It's a first episode, drug-naive. As I mentioned, previous studies, only one or two studies, they use first episode drug-naive MDD. And most of them use remitted depression patient. So the sample size is a little bit different. The discussion two, and the tryptophan metabolism, two important indicator is tryptophan and kynurenine, and there's no significant differences between the MDD and the healthy healthy control, which is consistent with most of previous study. But only we found the TBI is different. TBI is not a very simple ratio between tryptophan and kynurenine. It reflects the IDO enzyme activity. So in clinical situation, it's quite important, I would say. So we only have this positive finding. The cutoff, and beyond MDD, it has been reported use TBI cutoff can predict the prognosis of glioma by using immunotherapy. That's a paper from neurosurgeon. Maybe it's not very interesting and attract to you, but in neurosurgeon, they try to use this as an indicator. So this is the first paper we found. We also can use this cutoff as a clinical predictor, and since the value is different, they use 0.095. Our data is 0.056. So let's make a conclusion very fast. I don't want to occupy too much. First, this is the first paper. We found we link and we find some associations between the central and the peripheral markers. And of course, TBI opened a new era for the study for these two kinds of biomarkers. I would like to stress, when we did this study, I would say it's a pilot study. We know the serotonin transporter image for a long time, but it's the first time we do the plasma, tryptophan, and kynurenine. And we use commercial ELISA kit. This kit is very expensive. We should buy the kit individual to treat it, to measure the metabolite. The second is the data is quite unreliable. So now we are establishing a new lab. We bought two LC mass. We can simultaneously to measure the tryptophan metabolite downstream. So we can get more information just by one injection in LC mass. I would say in the future, we can revise our data, and I think it's will be very helpful. And we are also using this LC mass to establish the normal population data, since it's not very difficult now to use this one. So I would like to thank the SPECT Center in my hospital and the government funding for this study. Thank you for your attention.